Let us start our studies in chemical kinetics. Number one, and as we know that today we shall get an idea about what is chemical kinetics, what is meant by chemical kinetics, and how chemical kinetics is defined. But before that, I would like to let you know that there are certain terms which are commonly used during our studies on chemical kinetics, and the terms are elementary reaction, molecularity, rate law, integrated rate equation, order of reaction, mechanism of reactions, factors affecting the rate of a reaction, collision theory, Arrhenius equation, that is describes the effect of temperature. So at least these terms have to be uh, learned properly, and a clear concept of these terms is very essential before we get into detailed study of chemical kinetics. So today we start with our studies in chemical kinetics 1, and that is, here we shall get an idea about identification of the elementary reaction. What is meant by an elementary reaction? But before that, let us have an understanding about what is how to define chemical kinetics. Chemical kinetics is nothing but a branch of chemistry which deals with the rate of the reaction, factors affecting the rate of the reaction, and also the mechanism of the reaction. Rate of the reaction, when we talk about rate, means it is a relative term with respect to period or time, and therefore whenever a reaction takes place, some changes occur during the course of a reaction, and we measure these changes in terms of concentration. And this concentration of what? Concentration of either the reactants or the products. It goes on changing as the reaction proceeds. As the reactants are converted to products, the concentration of the reactant goes on changing. So rate of the reaction is nothing but is the change in concentration of any one of the reactants or even product. Any one of the product can be considered for per unit time as measured. And of course, the unit has to be concentration terms divided by the time terms. And usually for most of the reaction, the concentration is given in moles per liter. We have already learned about chemical equilibria, and there we have used the concentration of a particular reagent in terms of moles per liter. And of course, the time may be either in seconds, it may be in hours, it may be in minutes also, and it might be in days also for very, very slow reactions. So, but in most of the cases, a general unit of time which is used is second, that inverse, that is per second, moles per liter per second. And if there is a gaseous reaction, the unit has to be a pressure unit, that is normally atmosphere per second. So that's there. Now let us have an idea about what is meant by elementary reactions and reaction intermediates. Now we know that a reaction, whenever the reaction occurs, it has two parts: the reacting parts, the reactants, and the products. And we write a balanced chemical equation using their stoichiometry, and we get an idea about what is converted to what. Means what reactants react together in terms of masses, also their molecular weight or moles, and what are the products formed. So that is known as stoichiometric balanced equation. So through balanced equation, we get that what are the products and what are the reactants. But it doesn't give us an idea about how the reaction has occurred. What is the reaction path? That we don't get an answer to this question. So we need to evolve. We need to find out how the reaction has taken place, whether there is a single step reaction or a number of reactions have taken place, and then you have got the final product. So this is given by what is known as reaction mechanism. Very important. The reaction mechanism or the reaction path reveals details about the precise step-by-step process by which a reaction occurs. I'll give you an example. Ozone, of course, we know it is O3. Gaseous ozone is converted to oxygen on decomposition. So decomposition of ozone, two molecules of ozone gives three molecules of oxygen. But how? It doesn't occur by the collision of or the interaction of two molecules of ozone together. Rather, what happens that a single ozone molecule first changes itself or breaks into oxygen gas and atomic oxygen. This atomic oxygen again combines with oxygen and forms two molecules of O2 gas. So, the, what has happened? The reaction has taken place in two distinct, different steps of reaction. And these distinct steps of reactions are known as elementary reactions. Each of the steps in reaction mechanism is known as elementary reaction. So here in this particular case, there are two elementary reactions. And what has happened? Either a bond is broken and a new bond is formed. So as a result of this, two elementary reactions combine together to form the final stoichiometric balanced equation, which we write this way. And then one point is very important, which we need to understand, that some product is formed in between, which is used up in the subsequent reaction. And this is known then species produced in the step which is consumed in subsequent reaction is called in reaction intermediates, or simply we call it as intermediate. Okay, then the equation for elementary reaction represents a chemical change taking place on sequential step. The reactants undergo bond breaking and bond formation during a particular step. This I've already explained to you. And a rate law, of course, a new term for you. Rate law can be made out for a balanced chemical equation of elementary step. And rate law of elementary step can be given from the balanced equation, but the rate law of any equation cannot be given from its stoichiometric balanced equation. It has to be determined through practical experiments. And how this will be done, we shall take it up subsequently in our next talk. Okay, thank you very much. Please do subscribe and try to get the concepts we have started about chemical kinetics. Thank you again.